Okay, this doesn't tie in with a specific question, but I know it's something that comes up that might be confusing for some of you. So I want to make sure that we understand what the difference is between probability and odds for. Those are two ideas that seem really, really similar, and it can be easy to get them confused. But what I'm going to do is show you what the difference is in the definition, and then we'll talk about how to compute probability and odds for a few different things to show you how they're different when we actually figure them out. So what is the difference between probability and odds? Well, when we do probability, we do this fraction, and on top of the fraction are successes, right? These are the things that we're looking for. So if I'm drawing cards out of a deck and I draw one card out of a deck and I want to find out the probability of drawing a 4 of diamonds, there's only one 4 of diamonds in the deck, so that's only one possible success, so I would have a 1 in my numerator. The denominator in probability, and I should probably write probability here, probability has success in the numerator, and the denominator is all possible outcomes. Okay, so like I said before, probability of drawing 4 of hearts from a 52 card deck. Well, there's only one possible success. There's only one 4 of hearts in that deck over all possible outcomes. There's 52 cards, so I could draw any one of those 52. My probability is 1 over 52. Okay, so what about odds for? Odds for. What's the difference? Well, on the top of odds for, we're still going to have successes. But on the bottom, instead of having all of the possible things that could happen, we're only going to have the failures at the bottom, so the non-successes. All right, so in this case, odds for drawing a 4 of hearts from a 52 card deck, well, there's still one 4 of hearts in the deck. There's only one success possible. But instead of all of the possible things that could happen, all 52 cards, I only want the cards that aren't the 4 of diamonds. And there are only 51 of those. So if I pull a card out, there's one card that is my success card, that 4 of hearts, and the other 51 cards are not successes, they're failures. And something you're going to notice when you're doing this, or something that you might notice, is that when you take the numerator and the denominator from your odds and add them together, it would give you the total number of successes that you would put at the bottom of your probability. So there's kind of a relationship there, that if you add this and this, you're going to get that number there. But you want to make sure that when you're doing odds for, that you put the successes in the numerator and the failures in the denominator. So let's try another one. I don't want to just leave it at that. Let's do another one and compare probability. Whoops, I have already written on that piece of paper. Find a blank one. Okay, we're going to do probability over here. If we can see it, probability. And odds for over here. And so the example that I'll use for this one is going to be, let's do a dice. So we're going to roll a die, get an even number. Okay, so that's what we're looking at. So the probability if we roll a die to get an even number, well, how many even numbers are there on a die? We have 1, 2, 3, 4, 5, 6, 2, 4, and 6 are even. So there are 3 successes out of the all possible outcomes. Remember, probability is successes over all possible outcomes. We could roll any one of these, so we have 1, 2, 3, 4, 5, 6 possible outcomes. Our probability is 3 over 6. Now, what are the odds for rolling an even number? Well, we still have 3 successes, right? You could roll a 2, you could roll a 4, you could roll a 6. 3 successes, but on the bottom, the odds for on the bottom has failures. So we're not talking about all of the possible outcomes, we're only talking about the ones that aren't successes, so that are not even numbers. So that's 1, 3, and 5, so there are 1, 2, 3 of them. So the odds for rolling a die with an even number are 3 to 3. And that looks a little bit weird because they're both the same number, but that's absolutely accurate. And just like we saw with the odds for drawing a 4 of hearts, where the number of successes plus the number of failures equaled all possible outcomes, in this case, the number of successes plus the number of failures equals all possible outcomes. So understanding that relationship is important. There's a question on the homework, trying to find it here, that deals with those odds, where they're going to ask you to make a comparison between probability and odds. They will give you odds and ask you to come up with a probability. And so what I'll do is I'll do that one in the next video. But for now, just remember that the difference between probability and odds for is that probability, you have successes and all possible outcomes. Odds for is just successes and failures. And just as a quick note, odds against is just failures over successes. Okay, so in that case, when we were doing odds for drawing 4 of hearts from a 52 card deck, we came up with 1 to 51. Odds against, just flip it, 51 to 1. In the case for this one, it honestly doesn't make a difference. Odds for is 3 to 3. Odds against, well, that's also 3 to 3. So you could look at it, you could look at that one. Odds for and odds against are the same because the number of failures is the same as the number of successes. So we're going to take a look at some more odds videos, odds for and odds against videos for the homework help. So you can find those on the homework help site.